Picture this, a tiny, frozen world, drifting silently in the farthest reaches of our solar system, suddenly veering off course, hurtling toward a catastrophic clash with a gas giant. Pluto, the underdog of our cosmic neighborhood, might be on a collision course with Neptune, and two of the biggest names in science, Neil deGrasse Tyson and Michio Kaku, are sounding the alarm. This isn't just a wild theory, it's a wake-up call. What could cause such an unthinkable event? Could this distant disaster ripple across space and threaten Earth? And why now, after billions of years of peaceful orbits, is this tiny dwarf planet stirring up such cosmic chaos? Buckle up, because we're diving deep into the mystery of Pluto's perilous path, a tale of gravitational tug-of-war, orbital acrobatics, and the fragile balance that keeps our solar system spinning. Let's start with Pluto, that enigmatic speck in the void. Once hailed as the ninth planet, it was demoted to dwarf planet status in 2006, a decision that sparked debates and broke hearts. But Pluto doesn't care about labels. It's out there, 5.9 billion kilometers from the Sun, a chilly, rocky world smaller than our moon, shrouded in mystery. Its orbit is unlike anything else in our solar system. While most planets trace neat, circular paths around the Sun, Pluto's orbit is a stretched-out ellipse, tilted at a wild 17 degrees compared to the flat plane where Earth and others travel. It takes Pluto 248 years to complete one lap around the Sun. Since its discovery in 1930, it hasn't even finished a single orbit. But here's where it gets wild. For about 20 years in each cycle, Pluto swings closer to the Sun than Neptune, crossing the giant's orbital path like a cosmic daredevil. So why haven't they collided? The answer lies in a delicate dance, one that's held steady for billions of years, but might not last forever. Neptune, the deep blue gas giant, is a heavyweight in our solar system, 17 times Earth's mass, with a gravitational pull that commands respect. Pluto, by contrast, is a lightweight, barely a fraction of Earth's moon. Yet their orbits are intertwined in a fascinating rhythm. For every 2 laps Pluto makes around the Sun, Neptune completes 3. This 3:2 resonance is like a cosmic metronome, ensuring that when Pluto crosses Neptune's path, Neptune is always at least 90 degrees away, a safe distance that's kept them apart since the solar system was born. Add to that something called asynchronous oscillation, where Pluto's position in its orbit is perfectly timed to avoid Neptune, and orbital drift, which keeps Pluto vertically separated when it's near Neptune's plane. It's a gravitational ballet, choreographed by the Sun, Neptune, and even Jupiter and Saturn, whose massive pulls help stabilize Pluto's quirky path. But stability isn't guaranteed. Enter the three-body problem, a puzzle that's baffled scientists for centuries. When 3 massive objects, like Pluto, Neptune, and the Sun, interact through gravity, predicting their long-term paths becomes a nightmare. Tiny changes in speed or position can snowball over time, turning a stable orbit into chaos. Pluto's orbit, already eccentric, is especially sensitive. Computer models from the 1980s showed that while Pluto's path is stable for now, it's not immune to disruption. A slight nudge, a passing comet, a shift in Neptune's orbit, or even Jupiter's massive gravity tugging just a bit too hard could throw Pluto off course. And that's where Tyson and Kaku come in. These titans of science aren't just hypothesizing. They're warning us that Pluto's orbit might be more fragile than we think. If something disrupts that 3:2 resonance, Pluto could spiral closer to Neptune, setting the stage for a collision that would shake the solar system. Imagine the scene. Pluto, a rocky underdog, slamming into Neptune, a swirling giant of gas and storms. The impact would be cataclysmic. Pluto would likely shatter, its icy crust and rocky core disintegrating into a cloud of debris. Neptune, with its immense mass, might survive, but not unscathed. The collision could disrupt its atmosphere, sending shockwaves through its stormy clouds, maybe even altering its orbit. Debris from Pluto could scatter across the solar system, forming a new ring around Neptune or pelting its moons, like Triton, with meteor showers. But could this cosmic crash reach Earth? The short answer is no. Earth is far too distant, shielded by billions of kilometers and the gravitational grip of the inner planets. But the ripple effects could be profound. A destabilized Neptune might tug at Uranus or Saturn, subtly shifting their orbits, which could, over millions of years, nudge the delicate balance of our solar system. So how could this even happen? Pluto's orbit has been stable for 4.6 billion years, so why the sudden worry? The answer lies in the unpredictability of space. Orbital chaos theory tells us that systems like Pluto's are hypersensitive. A tiny change today, a fraction of a kilometer per second in Pluto's speed, could lead to wildly different outcomes in a million years. Back in the 1930s, when Pluto was discovered, astronomers were stunned by its odd path. Early calculations suggested it might be a rogue, destined to crash or be ejected from the solar system. But as we learned more, we found that Jupiter, Saturn, and Neptune act like cosmic shepherds, guiding Pluto's orbit through their gravitational influence. Jupiter alone, with its massive bulk, could keep Pluto stable for billions of years. Yet even Jupiter isn't infallible. A rare alignment of planets or an external force, like a distant star passing too close, could upset this balance. Tyson, with his knack for making science accessible, has long been fascinated by Pluto. He championed its reclassification as a dwarf planet, arguing it was a step toward understanding our solar system's true diversity. But he's also cautious, aware that orbits aren't set in stone. In his talks, he emphasizes how our knowledge evolves. Yesterday's planet is today's dwarf, and tomorrow's stable orbit could be a cosmic catastrophe. Kaku, a theoretical physicist who dreams in equations, sees the bigger picture. He's spent decades exploring the universe's hidden forces, from black holes to planetary orbits. Both scientists know that while Pluto's path seems secure, the universe loves surprises. A single perturbation could unravel the 3:2 resonance, sending Pluto on a collision course with Neptune. It's not a question of if, but when, though when could be millions, even billions, of years from now. Let's talk about the VZK wobble, a term coined by researchers studying gravitational interactions. Named after Zeldovich, Kolopov, and Kaku, it describes how three bodies, like Pluto, Neptune, and the Sun, tug at each other, creating subtle shifts in their paths. This wobble is why Pluto's orbit seems erratic yet stays predictable over long periods. It's like a cosmic tightrope walk, where each step is calculated but never guaranteed. The VZK wobble shows us that space isn't chaotic. It's a system of hidden rules, where even the wildest orbits follow a deeper logic. But those rules have limits. If Pluto's wobble grows too extreme, it could cross a tipping point, pulling it closer to Neptune's path. What's fueling this renewed concern? Advances in technology have given us a clearer view of Pluto's orbit. The James Webb Telescope, peering into the outer solar system, has revealed new details about distant objects. Automated observatories track Pluto's every move, feeding data into models that predict its path with unprecedented precision. These tools confirm that Pluto's orbit is stable, for now, but they also highlight its vulnerability. Simulations show that a small change in Pluto's velocity could alter its orbit in just a few centuries. Over millions of years, those changes could compound, bringing Pluto dangerously close to Neptune. Tyson and Kaku aren't saying a collision is imminent, but they're urging us to keep watching. The universe doesn't send warning signs, it just acts. Pluto's story is a reminder of how little we control in the cosmos. Since its discovery, it's challenged our assumptions. Its orbit defies the neat, orderly paths of the inner planets. Its demotion sparked a global debate about what makes a planet. And now, its potential to disrupt the solar system is forcing us to rethink stability itself. The 1980s models that first mapped Pluto's orbit hinted at this unpredictability. They showed that while the 3:2 resonance and gravitational tugs from Jupiter and Neptune keep Pluto in check, the system isn't foolproof. A single anomaly, a comet's nudge, a shift in Saturn's orbit, could rewrite the script. But let's zoom out. Why does this matter to us, here on Earth, orbiting a star in a quiet corner of the galaxy? Pluto's drama might seem distant, but it's a window into the forces that shape our world. The same gravitational laws that guide Pluto govern Earth's orbit, the moon's tides, even the satellites we rely on. Studying Pluto helps us understand the solar system's delicate balance, a balance that's allowed life to thrive for billions of years. If Pluto's orbit can falter, so can others. The chance of a Pluto-Neptune collision is slim, but it's a humbling reminder that our cosmic home isn't as predictable as we'd like. Tyson and Kaku aren't just raising alarms. They're inviting us to wonder. Pluto's journey, with its wild swings and near misses, is a testament to the universe's complexity. It's a story of resilience, where a tiny world defies the odds to carve its path among giants. But it's also a cautionary tale. The solar system is a machine with countless moving parts, and even the smallest cog can throw it out of whack. As we probe deeper into space, from the Kuiper Belt to distant galaxies, Pluto's orbit reminds us to stay curious, vigilant, and ready for the unexpected. So what's next? We keep watching. Telescopes scan the skies, computers crunch numbers, and scientists like Tyson and Kaku push us to ask hard questions. Will Pluto stay on its lonely path, or will it one day meet Neptune in a blaze of cosmic fury? The answer lies in the stars, waiting for us to uncover it. For now, Pluto drifts on, a small world with big secrets, challenging us to keep looking up, to keep exploring, and to never stop marveling at the universe's endless mysteries.